All right, welcome in everybody. Looks like we're gonna get started. Does anyone have questions before we get started here? No. Okay. Just making sure because I see there's a number of people in Zoom, so I didn't know if that was because people wanted to ask questions or what. Feel free to ask questions as we go. Okay, so reminder of how things are going this week. We're finishing up this chapter here. And then once we learn all that material, I will, next week is kind of our exam week. We'll have a practice test. We'll have reviews depending on if students bring questions. Reviews in my classes are largely student driven because otherwise, like I've already done a bunch of examples. Sometimes I end up doing examples that students don't need to see again. So if you send me problems, send me a screenshot, something like that, I can use that to decide what I should go over during the review. Right? But if no one sends me stuff, then I'm going to assume that you all are comfortable with how to do all the problems, and then we'll move forward. Okay. So this week we'll cover these last three sections. We kind of started special factoring, but we'll finish up these between today and Wednesday. And then next week I'll open up this. I'll release this and put proper dates on it and stuff like that. And then you'll be able to kind of get ready for the test. So there'll be the practice test, and you'll have a assignment here where you kind of help each other out and post questions and answers about the how to get ready for the test, how to do certain types of problems, stuff like that. Okay, so that's where things are going from there. A couple other things I wanted to mention. So I got an email. So in this class, there's a very low return rate for the student evaluations. You probably got an email to your school email account where you can answer your student evaluations. The response rate is very low, so I just got an email saying remind your students to do that. If you want to do that, go fill out an evaluation. Right, so there's that. Also the other thing is so the other thing is the school has changed their mind about something. So this situation where even though I teach 100% online and most of our professors this semester are 100% online, the school was still making us do at least 60% of our office hours on ground. Finally, the union and the school have come to an agreement and decided that was a silly decision. So for the rest of the semester, all of my office hours will take place on Zoom. So including the Monday office hours after today's class where you would have had to go to campus in order to talk to me, you now can just go to Zoom and talk to me. Okay, so that's better. I think that, I only had, for the whole semester, I only had a few students show up to those Monday campus visits because people signed up for an online course probably because they don't want to go to campus. And then on top of that, it's a little bit of work to get on campus right now. You have to get through the screening protocol and all that kind of stuff. So it's good news for me and it's good news for students both, right? I don't have to, and it just so happens now that my car situations are fixed and I can actually get around easily, now I don't have to go anywhere. But that's neither here nor there, I guess. But also it's good for students because now you don't have to go to class. If you want to get help from me on a Monday, you've got a few hours, not that you would stay for the whole hours, but, show up, ask me some questions. I can help you out and move you along past whatever log jam you're having in the class where you're if you're having trouble progressing, I can help you through that. Okay. So, including starting today. So you can ask me right after class, ask me any questions that you want, and I can help move you forward so that you're progressing through the course, successfully. Okay. So we'll do that. So really try to be focusing now on your homework. It looks like many of you are largely caught up on the homework or, within striking distance, maybe an assignment or two behind or something like that. But most of you are doing quite good. Keep that up. So go in there, make sure by the end of this week, like what would be great is by the time we meet a week from today, if you had all the homework assignments up to date. So that is you got through the solve by factoring and special factoring and all those assignments were all done. Many of you are very close or totally caught up as of today. Just make sure you're caught up by next week. That way next week sometimes what students do is they use the week that you're supposed to be studying for an exam. They use that to finish up their homework. And yeah, it's going to benefit you to work on the homework. But then you're not spending time studying because you're like, well, I got to get these points for the homework instead of working on the stuff, going out and finding how to do the stuff you don't know how to do. Excuse me. So, it's like I've had students come to me and they're like, well, I totally get, these special factoring using formulas, but I got to finish the homework. So they go spend an hour doing that instead of working on the problems that they need, that they need to get right. Maybe they finished the homework for an assignment, but they're still struggling with the problems. So that's kind of the way to go. Have your homework all completed by the end of this week. And then next week you can just focus on getting help from me in office hours, helping each other in the discussion here that you'll get 10 points for. Pretty easy 10 points. Just ask a question or answer someone else's question. And getting all ready, and then hopefully everyone does well on the exam, and then we don't even have to worry about a retake, right? I'll offer a retake if, it'll be there for you. It's your safety net, but it's nice that, hopefully if you do everything right between now and the time you take the test, hopefully you won't even need the retake, right? It's not the end of the world if you have to, but it definitely makes things harder, right? That means 2 weeks from now, you can either just spend the week working on new material, or you can spend the week working on new material and studying for the retake, right? Which one of those sounds more appealing to you? Probably just learning the new material, right? It's less work. So sort of invest in your time management now by making sure that you're all ready for the first time around on the exam. Okay. Great. Let's move forward then. So we talked about special factoring before. We basically have these 3 different situations where you need, can you give an idea of how many questions will be on the exam? I cannot at the moment, because I haven't even written the practice test. I'll do that by the end of the week. But, you can expect to see, of each major type of topic that we've covered, you can expect to see a problem like that. So there could easily be 7 to 10 questions just from this chapter. So the question I'm answering is how many questions will be on the exam. You could easily see 7 to 10 questions on here just because there's the different types of factoring. And so, there's going to be a difference of squares problem on the test. There's going to be a factoring trinomials with coefficient where your A is 1. There's going to be trinomials where your A is not equal to 1. You're going to have some factor by grouping. So you can kind of figure there's going to be at least probably 10 problems from Chapter 5. Probably a couple problems from Chapter 4. I don't generally go overboard with test problems from there, but there'll be a few from Chapter 4. Solving systems of equations, you can expect at least 3 to 4 problems from there. Solving graphically, solving with substitution, solving with elimination method, and then maybe even another 1 or 2 where you have to do it from a word problem, something like that. And then graphing, make sure you know how to do some graphing and that you're comfortable with functions. So, so I want to be careful. So the question is, so practice tests will sort of mirror the exam. I would say very, very sort of, but I definitely, I reserve the right to make whatever changes I feel appropriate between the practice test and the exam. Sometimes, and I know that the question in the chat is not trying to imply this, but sometimes students kind of get it in their head that what I'm saying is the practice test will be identical to the actual exam, which I know that's not the question being asked, but students will come to me and say, well, this isn't fair because this problem wasn't on the practice test. The practice test is just to get you working those problems. Some of these problems you did, 2 months ago, right? So it's just to get you to go through those problems again, remember how to do them. Sometimes all you have to do is do a few of them, right? Stuff we learned 6 weeks ago, and you go, that stuff, that stuff was not too bad. But if you haven't looked at it for 6 weeks, it's easy to forget, right? So sometimes just doing a couple of those, you go, oh, right, I remember how this works. And then you're good to go and to get that right on the test, right? But I definitely sometimes, not too much, but, sometimes there will be a student that's, they kind of like, well, you changed this problem on the practice test to this other problem. I'm not big on surprises or trying to trick people. I just don't see that being I don't see the point of that. You've probably all had teachers along the way that are known for like brutally hard tests. Even when it's math majors, I just don't see the point of trying to be, just destroy people. I'm not sure what the point is in that. So really, I'm just trying to test you on the material. So every type of problem that you do will either look like a problem that we've done in class or a problem that's on the or that was on your homework, right? You're not going to see some crazy new problem that like you haven't had any experience with. It will be pretty closely related, right? Or close enough that we can make the case, or I can make the case that it's similar. So, maybe on the practice test, I give you 3 factoring trinomial problems. Well, maybe on the actual test, one of those factoring trinomial problems is changed to another solve equations by factoring or something like that. So the problems, there's going to be a little bit of variation in the problems, but again, I'm not looking to trick anybody, right? The practice test is just to get you to do problems, again, that were already like your homework. Go back, remember how to do those, and then you should be ready to hopefully, what you want to do is use the practice test as feedback as to what you need to go work on, right? You might go, oh yeah, I remember chapter 4 being kind of hard, but I fought my way through it, but now I've forgotten some of that stuff. But it'll kind of clue you into what you need to go back and look at, and then you can do well on the test. So, like I say, not looking to trick anybody. The practice test will be under the same rules as the homeworks. So anything that holds for the homework, the practice test will be like as well. Now, Delta Math did an update, and they changed the way the tests work. So I'm still kind of figuring out the details of the new system about how tests work. They seem to have changed the time frames a little bit, which is throwing off how I like to give exams online. But yeah, the practice test it'll basically just like be like a big long homework assignment that kind of covers the whole course. The practice test will be longer than the actual test. I don't do it the other way around where I make the test longer. So if you're working through the practice test and you're like, this is taking me forever, it's also, I'm not trying to make the practice test super long, but it is a little more comprehensive than the actual exam will be. But just realize the actual test will probably be shorter than the practice test, so don't totally panic. But also, I'm not going to have like a time crunch on the test where it's like, okay, you have 50 minutes to complete this assignment, now get it done. You will have time to work through the test at a leisurely manner so that you're not rushing. That's another thing I've never understood is giving people math exams under like a time crunch where people are like racing through. That's never done in real life, where you have to figure out a math problem, and someone's standing there just like, hurry up, you're about to run out of time, time's running out. Like, that's not how math is done. So you can work through at a calm, leisurely pace where you don't have to get anxiety that you feel like time's running out and I only have 4 minutes per problem or something like that. You'll have plenty of time to work through it. Can we take the practice test more than once? Yeah. Oh, that's right. I already read that one. Yeah. So it'll be just like homework where you can go through and you should be able to revisit the problems and look at them and stuff like that. Yeah. Okay. Yeah. All good questions. Glad people are asking these questions, and feel free to ask more if you need more clarification on how things work. Whoops. I didn't get my book open and ready, did I? Here we go. Luckily, I have it bookmarked to the right page, so it's right here. Okay, so we're getting into 2 other types of factoring where basically you need the formula. So remember we did difference of squares. I went back and double checked where we left off last time. We left off with difference of squares, so I was doing some difference of squares problems. And basically you need a formula in order to do the difference of squares problems. The good news is most people memorize those problems pretty quick. Most of you kind of probably had that pattern recognized and memorized before we were done. And but certainly if you didn't, and that's okay if you didn't, but you'll probably have it memorized by the time you finish the homework. You'll have that part figured out. We have 2 other types of problems that require formulas. Technically, there's the books like to throw in a 3rd one, but I actually prefer not to teach that method because you don't need it. you can, like, it's a formula for a type of problem that you already know how to factor. So I usually leave that one out because you already have 3 formulas to learn. I don't see the point in making you learn what is actually 5 formulas. So 2 of them you don't need to know. 3 of them you have to know. You cannot factor the types of problems without them. So usually I just say, let's stick to the 3 that you absolutely need to know. And then the other 2, if you want to learn the other one's called, I forget what the name of the other 2 are. Let's see. It's basically the squares where you have the binomial squares, how to factor those. So we learned about them when we did the multiplying. It's just working backwards. But you just factor those like normal trinomials, so you don't have to worry about it. So we've already learned 1, difference of squares. You need that formula. We're going to learn 2 more that you have to have the formula for. Okay? And they're not like a super trivial formula. They're not as easy to pick up as the difference of squares formula is, but we'll take a look at those formulas and we'll see they're not actually as scary as they look either, right? They're actually not too bad. So the first one we've got is called difference of cubes. And the difference of cubes, right, you can imagine from sort of thinking about what we did with difference of squares, difference of cubes is just where we're going to have a, oops, let me move this back over. There's going to be a subtraction, and there's going to be cubes in it. Remember, the difference of squares was literally 2 squares and then a subtraction in the middle. Well, difference of cubes is 2 cubes with a subtraction in the middle. So your formula for this, when you want to factor this, is that a cubed minus b cubed equals a minus b times a squared. So let's see, I got to get my signs right. So this is going to be plus ab plus b squared. Let's see, what are we doing here? Okay, so this is your formula. This is how it breaks down. So remember what I talked about last time, which is anytime you do one of these problems, I highly recommend just write the formula out, and then underneath it, you just sort of model the formula and then fill the pieces in. Okay, if you do that, most people do perfectly fine on these. There are a couple places where students make a mistake, but again, that's usually because they're trying to hold the formula in their head at the same time they're trying to substitute into the formula, and then that can lead to a mistake, which ends up missing the problem, right? So let's do this one. Let's say we've got 8x cubed minus 27y cubed. There we go. It was taking a second. So the problem we're going to do is 8x cubed minus 27y cubed. Sorry, 8x cubed minus 27y cubed. So you can see that's what we have, right? This is a perfect cube. This is a perfect cube. We've got a difference in the middle. And you might go, well, how do I know it's a cube? Well, the variables are being raised to a multiple of 3, which means it's a cube. And then also 8 is a perfect cube. 27 is a perfect cube. And remember, this is like some of you are not familiar with your cubes yet. You're going to get comfortable with them as you do the homework problems. 8's going to come up a lot. 27's going to come up a lot because 8 is 2 cubed. 27 is 3 cubed. But cubes get big real fast, right? 10 cubed is 1,000. It's a pretty big number. So you can see these numbers grow so fast that we don't usually give you really large numbers. We kind of use smaller ones here. So yeah, so someone's mentioning in chat about SOAP, and we're going to go over that. SOAP is a great way to remember the formulas. I found it works really good for students. It really kind of ties all those formulas together. And once you spend a little time with the formula, you go, oh, okay, that's actually not too bad to remember. So we'll go over that. If this formula seems intimidating to you, we're going to talk about how you're going to remember it. Yeah, and part of it is SOAP. It's an acronym that we're going to go over. Yeah, so that's great. So what you do is you identify the A. So you go, okay, what is being cubed to give me this value? Well, I would cube 2x, right? So my A is 2x, and my B, so what do I cube to get 27y cubed? I would cube 3y. So my B value is 3y. And basically at this point, we've done the hard part. Now what we have to do is go through and plug these into our formula for the A's and the B's. So I'll plug it in for the first one. This one's pretty straightforward. That's going to be 2x minus 3y. Okay. Now right here, see where this a squared piece is? This is where most of the mistakes occur if you're going to make one in this problem. And here's the problem. Here's what I see students do is they go, oh, a squared, my a is 2x, and they'll write that this is 2x squared. Right? That's what this a squared piece is, students say. But that's not right, is it? We were supposed to square 2x. Well, 2x times 2x is 4x squared, not 2x squared. So this, I would say 80% of the time when students miss problems, it's right here in this piece. So just remember when we square it, you have to square the number 2, making this a 4x squared. Hopefully that makes sense to you, because then that means that you probably won't make any mistakes on this problem. Okay. All right. Then we've got plus AB. So A times B is 6xy. So I'm going to get plus 6xy. And then plus B squared would be 9y squared, right? And there we go. We've got that thing factored. We're good. We just factored that as a difference of cubes. So see how it was written originally as a difference, but now it's a product. It's two things being multiplied together. That's the whole point. These will come up occasionally. Those of you who are going down to calculus or pre-calc, these will come up once in a while, but you're actually not going to see them a ton. You'll need to know them enough because, you know, your calculus teacher will probably give you times when you have to use this, but this is one of the ones you're not going to see as often. But you certainly have to know how to do them now, because for sure there will be a difference of cubes or sum of cubes problem on the test. You'll have to do one or the other, maybe both. I haven't written the test yet, but okay. So that's how it is. You just follow that formula. So let's continue, and then once we do one more problem, then we'll take a look at the formulas, and I'm going to explain how you can remember how the formulas work. Okay? So now we look at sum of cubes. So guess what sum of cubes look like? Can you guess? It's going to be where we have two cubes being added together, right? It's literally a sum of two cubes. Okay? And this factors as a plus b, a squared minus ab plus b squared. Which at first might seem scary because you're like, that one's kind of like the other one. I think I'm going to mix up these two formulas and get them confused with each other. The good news is, you know, we can look at some stuff, and then using that SOAP acronym, we can actually use the fact that these are very similar to help us remember them. So while it may seem at first like it's going to be more confusing, it's actually going to be less confusing. But we'll get to that in just a moment. Okay? So let's say this is... yeah, let's do... see, we've got... let's see, we did 2... let's do 125x cubed plus Even 6 starts to get kind of big. So let's see. Let's make it just, we'll do 8y cubed. Okay. So just like last time, we've got our new formula. We're really going to approach this problem the same way. The only difference is that our formula is a little different. Okay, the formula that we're using at the beginning. Let me even put one more little space in there, but we have room for everything. Update there. There we go. That's formatted a little better. We can see the difference between those two problems a little bit better. Okay, so we're going to basically follow the procedure we did up here, except we're following a slightly different formula right here. So I have to identify my A. You go 125, that's so big, but again, just go through your cubes so you find it. Well, I know that 3 cubed is 27. 4 cubed, let's see, 4 times 4 is 16, times 4 is 64. Okay, 4 cubed is 64. What about 5? 5 times 5 is 25. Times 5 is 125. Okay, so A is 5x, right? 5x times 5x times 5x is 125x cubed. And for B, hopefully you're already kind of going, oh, I know that one. That's kind of, it's like from the last problem. It's going to be 2y, right? 2y. And now we're just going to go back and we're going to plug things in. So we're going to go, let's see. So A plus B is just going to be 5x plus 2y. Now remember the a squared, I have to square the coefficient as well. So it's going to be 25x squared. Now minus this time, this minus from our formula. A times B is going to be 10xy. And then our last term will be plus 4y squared. Okay, so we're just following the formula and plugging in those A's and B's. If you're confused by what I'm doing, if you're not following along, ask a question so I can help you out with that, okay? So I can be aware that we need to go, oops, looks like we went slightly off the screen there. Let me do this. Let's even move it over a little bit. Let's see, I'm going to have to play around with this because I need to talk about it. There we go. That'll work. Okay, so we've just done a difference of cubes problem. We've just done a sum of cubes problem. Follow along the videos. It's just getting comfortable with the formula and plugging them in. Now, when you're doing the homework, you don't really have to have the formula memorized. You can just have it written down like on your scratch paper or something, right? But you should try to memorize these formulas, okay? It's one of those things that's going to be helpful to you when you're, in calculus or whatever, and they're asking you to do it, and and you don't remember what the formula is. Let's see. Those should be, yeah, so sometimes you'll see different ways of writing them out, but these should be. Okay, so here's what you want to notice about these formulas. And here's what I recommend when you're trying to learn a formula is, first of all, there's a question. Let me answer this. Good. So the 4y squared is because it's multiplied by 2? No, it's because it's squared. So the 4y squared is because this b squared, we're multiplying 2y times 2y. So 2y times 2y becomes 4y squared. So you're taking whatever your b value is, this says to square it. Well, the square of 2y is 2y times 2y, which is 4y squared. Okay, good. That makes sense. Okay. Yeah. Right. Okay. So how do you remember formulas then that you're trying to learn? Well, there's a couple ways to do it. One is, like, see how I'm recommending, I keep talking about this, every time you do a homework problem that involves the formula, you should write it down on the paper because it's actually going to guide you through the problem, right? Why would you try to like visualize it in your head when you can write it down on the paper and just write things below what they are? It makes it way easier and less likely to make a mistake. But also, if you think about it, each time you write the problem out, you're going to learn it a little bit more, right? So if you do 10 homework problems, that means that, you may have had to write each of these formulas 5 times. You might just have it memorized by the time you're done. You might just know them. Some people will. Some people have better memories than others and they pick stuff up quick. Some people may just be able to get it that fast. Some people may not. You still have to take a little bit of work. But if you write out the formula each time you use it, you're going to learn it pretty quickly. Okay, so what else can you do then if you still don't have the formulas memorized at that point? Well, now is where let's talk about the SOAP that was brought up earlier. If you look at this formula for difference of cubes and this formula for sum of cubes, what you notice is that the only difference is the signs, right? The actual terms are the same. A cubed, B cubed, B cubed, A, B, A squared, AB, B squared, B squared. So the algebraic representation is the same. It's just the signs that are changing between the two formulas. And you're like, you can go, it's fair enough to say, well, that's still kind of confusing. It is, except the acronym SOAP. Let me write it in here. I think there'll be room on the screen there. SOAP. There we go. SOAP stands for same, opposite, always positive. So remember, you're going to be given a problem like this that needs to be factored. So you're going to look at the sign that's in the problem that you're working on. The next sign that occurs in the formula is the same, right? So that's the S, same. The next sign that occurs in the formula is opposite. And the last sign that occurs in the formula is always positive. So you get same, opposite, always positive. And look, it works down here. Here we started with a plus. The next one's the same. The next one's the opposite. The last one's always positive. So if you can remember that it goes A, B, A squared, AB, B squared, you can fill in the signs by just going, same, opposite, always positive. And then it's pretty straightforward. Okay? So that's how you can, that'll also help you with, if that requires a little bit of focus and thinking, but if you kind of get what I'm talking about with this SOAP, it can definitely cut down because, in math, we actually prefer that people not memorize things in mathematics because, we're in a day and age where if you ever actually need to know a formula, you just pull out your phone and you look it up, right? You just go, okay, Google, what's the difference of cubes formula? So it's not quite as important that it used to be that we have all these things memorized. We see a lot of that in stats and trigonometry especially. Trigonometry used to have so much memorization. And some of the stuff now, it's like you need to memorize the basics because you use them on every single problem. But like you don't have to memorize things the way they did, 40 years ago before the internet. So it's kind of nice. But this is one of those cases where you're going to have teachers that expect you to at least have memorized it. And what I found is, in general, the students that don't have these formulas memorized don't do the problems well. The students that have memorized them do fine, right? Even if you give them the formulas, a lot of times students just haven't spent enough time with the problems to be able to use the formulas. So that's, even though I'm not a big fan of memorizing formulas, I think in this case, it's actually helpful to learn how the formulas work. Now, if you've done all that and you're still having trouble memorizing the formulas, here's what you got to do. And this pretty much will finish it off for everyone who's still struggling with the formulas. Take the difference of cubes formula and write it maybe 50 times and say it while you're writing it. A cubed minus B cubed equals A minus B times A squared plus AB plus B squared, right? And it sounds like, oh my God, I'm supposed to write this 50 times. But if you say it along as you write it, your brain almost like a nursery rhyme or something where your brain just kind of gets into a rhythm. It's like when you learn the lyrics to a song and they get stuck in your head, or the melody or something. It's kind of like that where it'll get stuck in your head if you're saying it while you're writing it because you're using two parts of your brain to speak and to write the same thing. And, sometimes when I say that, I'll get pushback and students are like, 50 times? I'm supposed to write that 50 times? But think about it. If it takes you, I mean, what's reasonable? 5 seconds? It takes you 5 seconds to write the formula and say it. That means you can do 12 a minute. That means it's going to take you just over 3 minutes to have the formula. That means in 3 minutes you could have this formula memorized. All right, and it may not even take 50 times writing it out. So it's one of those things where students psych themselves out and they're like, 50 times, that's crazy. It's like 3 minutes from now you could have this formula memorized. So it's not actually that much work. Okay? And then just do the same thing for the sum of cubes. And then that, again, memorization, the reason we don't like it in math is that it's easy to confuse and mix things up. But if you have SOAP to fall back on, then you should be good to go. You just go, oh, that's right. Same, opposite, always positive. I should be good. And then you can kind of and you kind of remember it. Yeah, and then you can get to the point where you look at these so much that you're sort of dreaming about the formulas. But hopefully it doesn't. Hopefully you can still get a good night's sleep and it's not bothering you when you're trying to get some rest. But yeah, so learn those formulas. It's a good idea. Like I say, then you get those problems right on the test, and then, hopefully not have to do the retake again. Okay? All right. So that would finish up the special factoring. Okay? So I'm going to take the remainder of today to talk about factoring strategy, which isn't necessarily its own homework problem, but I want to talk to you about strategy for understanding what the problems are going to look like going forward. And how to think about a problem and go, how do I decide which method to use for factoring? And if some of you did what I suggested early on, where you were really looking at the clues of the types of problems that you were working on, then many of you are probably almost there already to getting how the factoring strategy works. And then next time we'll spend the whole time talking about solve equations by factoring, because that's the first time we actually put factoring to use to do something useful. So far we've just learned factoring for the sake of factoring, and it's pretty reasonable for students to go, who cares? We've written this thing as a product that used to be a sum. Why would I care about that? We'll start showing you, because the answer is factoring is one of the most useful things in algebra. Highly useful, but we'll see. We'll start solving equations that we previously didn't have any way of solving, right? We didn't know how to solve those. So here's how the strategy, Oh, and did I mention I changed the dates for a couple of the homework assignments because a couple of them were actually due yesterday. So the more recent ones, I went and changed them so you have more time to work on them. Okay, for the older assignments, you'll get half credit if you keep working on them. But some of these I went and, you can't see the dates because of where it is. But I changed the due dates. So if you didn't get those assignments done, you still can. Okay. Oh, right, factoring strategy. So let's look at that. So basically what the factoring strategy is, what should your mental strategy be when someone hands you a problem and says factor this? What should you do? So here's our strategy. Because, it's easy to kind of fool yourself and think, no, I'm pretty good. I've been going through the homework assignments and I'm able to factor stuff and things are going well, and that's fine. That's good. That's a good sign. But you've also had an advantage in that the name of the homework assignment was the strategy you were going to use to factor, right? So, the homework assignment that had factor by grouping in it, you were going to use factor by grouping. The one on trinomials, you're going to use trinomial factoring. The one on special forms, you're going to use a formula, right? So there's already a big clue in the problem because that's the title of the assignment. But that's not going to, for the remainder of algebra starting now and continuing basically for the rest of algebra, right, including college algebra, pre-calc, calculus, all that kind of stuff, when you have to factor, no one's going to tell you how to factor it. Your teacher's just going to expect that you can get it factored. So you're going to have to look at it and go, oh, I think that's a difference of cubes. I better use that formula. Or I think I'm supposed to use factor by grouping here. Or, ooh, that's a trinomial where the a is not 1. I better use the method that I like to use for that, because you kind of have two choices there, right? So here's the way that you want to think about your strategy. Step 1, I'm just going to use S for step. So step 1, in fact, I'm just going to use a 1. There we go, even better. Okay, step 1, you're going to factor the greatest common factor. That is always step 1 in these problems, right? Factor out the greatest common factor. Factor out the greatest common factor. It's always step 1. There's 2 reasons why it's step 1. There's 2 types of problems. Most of the time, you're going to run across problems where there is no greatest common factor. Or technically, I should say, the greatest common factor is 1, but it doesn't do any good to divide out a 1, right? Because you just get the same thing again. But when you do run across a problem that does have a greatest common factor that is not 1, it falls into 2 cases. 1, the problem is either going to be much, much easier to do when you factored out the greatest common factor because your exponents will be smaller, your coefficients will be smaller. It's going to be much easier to work out. So factoring out that greatest common factor right at the beginning of the problem, best way to do it. I do see students, sometimes they don't recognize there's a greatest common factor, and then they'll do the problem the long way. And they'll get it sometimes, but like, man, they did it a way that was way harder than it needed to be. Good for them, because they obviously know what they're doing, but they just didn't recognize there was a greatest common factor, and then there was like a lot more choices to check, right, if you're doing the trial and check. So it saves you a lot of work if you factor out that greatest common factor at the beginning. Also, there are certain problems that literally you can't do until you factor out the greatest common factor. I think we're not going to have time for one, but I doubt we're gonna have time. But just be aware of that. Like, for instance, if you like a lot of times in math classes, this is a real popular one. You'll look at a problem and you're like, I think that's supposed to be a difference of squares, but those numbers aren't squares, so I can't use the difference of squares formula. What'll happen is you factor out the greatest common factor, and then what you're left with is a difference of squares, and then you factor the difference of squares. So that's the kind of stuff too that like you can't factor that problem until you factor out the greatest common factor. So always step number 1, factor out the greatest common factor. Step number, where's my typing going? There we go, 2. Step number 2 is to count the terms in the polynomial. Did I get that? Oh, I even got it right. I thought I typed that wrong. Count the terms in the polynomial. This is going to be your clue as to what type of problem you're dealing with. Okay. So if there is 2 terms, like here's the possibilities, right? We'll sort of go begin itemize. Okay, so 2 terms. So let's just think about it for a minute. See if you can get them before me. Which type of problems did we do that had 2 terms in them? It's the ones we just talked about, right? The ones that had formulas in them. Difference of squares, sum of cubes, difference of cubes. Right? Those 3 have formulas. Also, I don't know if I pointed this out last time. There is no sum of squares formula. There is a sum of cubes formula. The sum of squares, you have to have complex numbers, and we don't factor over the complex numbers. So just recognize there's no sum of squares. There's difference of squares, difference of cubes, sum of cubes. Those are the 3. So if there's 2 terms, your first thing, what should go up in your head? Little red flag should say use formula. One of those 3 formulas that we're used to, right? Okay. All right, so that's one possibility. Okay, what if there are 3 terms? Well, if there are 3 terms, then this is a trinomial, right? So use trinomial. Use whichever you like to use for trinomials, use that. So remember, there's the possibility of guess and check, right? Guess and check is a legitimate way of factoring trinomials, and you kind of use those clues to narrow down the number of possibilities, and hopefully you get it in the first one or two. Yeah, so there's a question to me. Yep, I'm going to stick around after class. So anyone who wants to stick around and talk to me after class, you are welcome to do so. Okay. So if you like to use the guess and check for trinomials, do that. If you like to use the grouping method that I showed you for trinomials, use that. They're both legitimate for trinomials. So whatever your preference for methods for trinomials, use that. Right? You probably can recognize trinomials and go, oh yeah, this is a trinomial I'm dealing with. Okay. What if there are 4 terms? If there's 4 terms, it's going to be factor by grouping. So if you can kind of remember this, it's really going to narrow down. I see students sometimes, they'll have a polynomial on their page and they're like, I can't figure out which method I'm supposed to use. Follow these. You do the greatest common factor, then you count the terms, and the number of terms available are going to clue you into which type of factoring you need in order to factor that problem successfully. Okay? Now, you're going to start seeing more, right? We didn't throw you at these because you were just learning how to factor, but now that you hopefully have learned the factoring methods, you're going to see problems that require repeated factoring. It looks like I'm going to have just enough time to do the problem I was talking about a moment ago. So let's do that one. So let's go down. This will include the 2 things I was talking about. So let's say you see a problem. It says factor, and it's let's see, 8x squared minus 50y squared. All right, you're supposed to factor this as soon as it compiles. There we go. 8x squared minus 50y squared. And you're like, oh, that looks like it's going to be difference of squares. But wait a minute. 8 is not a perfect square, and 50 is not a perfect square. So what am I supposed to do here? Remember, step number 1, factor out the greatest common factor. And you go, oh, that's right. Right? And you go, oh, well, it looks like the greatest common factor is 2. So I'm going to factor that out. That leaves me with a 4x squared minus 25y squared. And then now look at what's in the parentheses. That is a difference of squares. So now you would apply the difference of squares formula. Just leave that 2 out front for now. We'll talk next time about why that 2 is important. Sometimes students have a tendency for that 2 to disappear. You can't. It's really important. So make sure that you leave that 2 out front. You don't have to do anything with it. Just keep writing it out front. And then this will become 2x minus 5y. And this will become 2x plus 5y. And there you go. So see how we could not factor this until we factored out the greatest common factor? Once we did, it's just a straightforward difference of squares problem. But notice how it took 2 factorings, a greatest common factor and then a difference of squares. You're going to have problems that have that. You might have a multiple difference of squares problem, right? We can come up with those where you actually have to do difference of squares like 3-4 times in a row. So just always, whenever you're done, just look at what's left and ask yourself, can I factor that again? And if the answer is yes, then do it. If the answer is no, then of course you don't do it, right? Okay, so yeah, so that's how that's going to work, and it looks like we're right on the dot here at 10:50. So I'm going to shut down the YouTube stream, but I'm going to stick around in Zoom, and actually I'll be in Zoom for about 3 hours now. For anyone who wants to ask me any kinds of questions, hop into Zoom and talk to me, whether it's about homework, the class, you're nervous, whatever it is you want to talk about, hop over, speak with me, and I will definitely help you out with that, okay? All right, thanks everybody. We'll see you in a couple days.